Welcome back. This is John Locke, and today I want to not only talk about this article from SEO theory, but I want to talk about some things, some kind of just ideas, and bounce them off you. And the one thing that I want you to take away is the same thing that I always want you to take away from stuff when we're talking about SEO is to always challenge what you're thinking and to always challenge your assumptions. And, not just straight science, but don't take anything that you hear for granted. Don't take anything that you hear as the gospel truth. And always, always, always challenge everything. Okay, the hard part about this. Everybody is looking for Google to give them the answer. Everybody is looking for Google or whoever to give them the set of instructions that if they follow each and every time, then they're going to have SEO success and rank #1 every single time. The problem with this is that Google itself is changing on a daily basis, because what Google is really trying to do with their search engine is replicate the way that a human mind thinks. And a machine is not a human mind. Though that's trying, they're trying to put together like neural nets, and they're trying to put together search engines that replicate the way that a human thinks. And they are getting closer, but it's not there yet. But it's way closer than it was 20 years ago, 15 years ago, 10 years ago. It's way closer than it was. Okay, enough on that for a second. Just keep all this in mind. This article by Michael Martinez, I've seen some of his stuff before. Some of it's okay. And some of it, like I said before, it gives me ideas. It reminds me of stuff. A lot of times people say things, and whether I agree with them 100% of the time or not, it doesn't always matter. But I get ideas from a lot of places, and then it's things that I test or things that I observe. But what he's talking about is vectors. So he's talking about vectors as being a class in linear algebra, the algebra of lines. I don't know how many of you took geometry or trigonometry or calculus or these sorts of things back in high school or college. I did. Been a long time, but I do remember all this, kind of. And a lot of this brought it back, kind of brought it back. But when you're talking about classes, you're taking a class of quantities or entities and you're defining them as an algebra. Come up with rules, and those rules basically become that class. Right. But what he's talking about here are sets. Okay, this all makes sense in a minute. Stick with me. So he's saying here's these like little sets, X and Y sets. 0, 1, 1 and 2, 2 and 3, 3 and 4. Those are each points. Put together, they make a line. Okay? They make a line segment, I should say. Okay. If you're following so far, each one of these, right? Okay? But they're represented by a vector. This pattern that is the same, where the X and the Y go up by a value of 1 each time. That's a vector. Okay? He's saying this is a line segment too, doggy, pony, fishy, tree. The difference between these line segments is the first is mapped to a Cartesian plane, Rene Descartes, defined by 2 infinite number lines, and the second is mapped to an abstract algebra defined by an arbitrary list of things represented by at least those 4 words. You can put anything into vector form. Okay, now, if you're thinking about it like that, anything can be a pattern as long as you have defined sets of rules. Okay? We're talking about computer scientists. They're strongly influenced by mathematics. Took up the challenge of creating algorithms that understand language. Okay, the first point that I want you to take away from here. So far, there are no algorithms that understand language. Not completely. It's getting closer. But it's trying to, but it's not at the point where it understands it the way that a human does. To understand something is a very complicated process, and we don't really know what that means. Animals have understanding, and one of the coolest new findings in language science is the fact that prairie dogs have the ability to describe me or you in rather fine detail to each other. Yes, there's bona fide prairie dog language, and it has many dialects. And the fact that they have language that allows them to describe abstract things such as human in red walking through a colony versus mountain lion eating our friends, meaning that prairie dogs understand things. They understand things semantically. Okay? Now, we know that prairie dogs do not use vectors to understand anything, but some computer scientist somewhere is pondering the challenge of representing prairie dog language in vector form. Vectors are a tool used by computer science to analyze language. We won't dignify them by saying that we use them to understand language, but the similarity between the concepts is superficial. So far, what Michael is saying is vectors are used by computer scientists to map patterns and try and have understanding. Okay, pattern analysis is really easy to do. The next section, he's talking about computer science looks for patterns. All right, it's much simpler than understanding language. The vectors make it easy to do pattern analysis. Mathematicians and computer scientists have been using vectors for pattern analysis for decades, going back to at least the 40s. Any line segment is a pattern. The points make up a line segment. The line segment is an implied infinite line. Okay? A complicated pattern consists of many different line segments that are somehow connected. And since you can represent a line segment as coordinates, you can transform those coordinates, meaning you can take the pattern that is a line or a complicated line segment and transform that into something else. That's a vector. Okay? So a simple, somewhat misleading terms of a transformation consists of adding, subtracting, dividing, or multiplying a value. So if you have a vector like, remember these are x, y axes, okay? If you have a vector like 0, 1, 1, 2, 2, 3, 3, 4, you can transform it by moving it 3 points higher on the y-axis, such as 0, 4, 1, 5, 2, 6, 3, 7, or 4 points farther out on the x-axis, like 4, 1, 5, 2, 6, 3, 7, 4, or both. And it has a similar pattern. So that's the whole thing of human understanding, is seeing the patterns and understanding them. That's what computer scientists are trying to do. And I think what he's trying to imply here is that is what the algorithm, the Google algorithm, tries to do when it tries to figure out what's in a page. And you can go back and watch the video that we did on the natural language API, and it talks about that, and it shows the progress that Google is trying to make, and other search engines as well, is trying to semantically break down patterns in language and understand the meaning of those pages. Now, it is a lot more complicated than it was 15 years ago, when all you had to do was repeat a keyword in a page or a document enough times. That was relevance. Okay, we're way past that now. So we're looking for similar patterns. Just as with a Cartesian sense, you're looking for similar length and angle among line segments. In pages that can satisfy a search query, you're looking for similar patterns. And he says right here, that's what machine learning is all about. It's looking for patterns. Okay. Modern machine learning owes much to optical analysis. And there's a community called Kaggle, which is about machine learning and data scientists, founded in 2010. Google acquired this in 2017. But they used to sponsor machine learning competitions. But there's publicly available data sets that people can use for experiments. Okay? So in 2018, Google announced it was using neural matching algorithms in 2018, and a lot of people wrote about it. And, a lot of people put out what they thought it was. Okay? And he talked about it here. I didn't really read that part. But anyway. The U.S. government developed neural matching as a way to compare satellite photos to maps, converting images to systems of vectors and looking for patterns. So you can take two images from different sources like maps and photographs and convert them into a similar format, a system of vectors, and look for similarity. This is what facial recognition and all these things, the same thing, does. Now, it's a lot more complicated than that, but the human brain can do this very easily. It can look at a map, like a flat map, and it can look at an aerial photograph and recognize the relationship between the two things, even though they're completely different. The human brain can analyze that very quickly. Okay? Computers, trying to get there. The analog information is converted into vectors. Okay? So You can digitize any analog data. This is data sets, not just raw data, but turning it into information. Okay? Okay. So, he talks about how semantics, like machine semantics, is really looking for pattern analysis using linear algebra, machine learning, digitizing words, looking for patterns. This is what the natural language API is doing. It's trying to figure out how to put some meaning into words on a page, okay? And figure out something. Now, something that I want to interject here, and again, this is about this point when I was reading this the first time that I thought of something. Now, at the very beginning of this, I said, sometimes I'll hear things, I'll see things, I'll read things, and it'll remind me of something else. It won't be the information that I'm reading on the page, but it will remind me of something else. Okay? That's how a human brain works, but what this, now, the first time that I read this, what this really clicked in my head, like right at this point, was Google isn't simply looking to understand the words on a page and say, this page is about whatever, this subject. This page is about construction. This page is about manufacturing. This page is about auto repair. This page is about digital marketing. It's not just about that. The level that what they're trying to achieve is saying for any given query, any given search query, we want to rise to the top the pages that are going to make searchers the most happy. It's not just saying, what is the subject of this page about? We want to actually surface and rank the pages, the documents that are going to make the searchers the most happy. That's what I realized right at this point. So when we're talking about machine learning, we're talking about pattern matching, we're talking about vectors and algebraic data sets or whatever. The only thing that you really need to take away from this is the Google algorithm looks for patterns of pages that in the past have made people happy when they've searched for specific queries. If they've typed these certain words and done this certain search, they're looking for pages that fit a pattern that have made people happy in the past. That's what this is about. That's the philosophy that at least I think that you should be having when it comes to SEO. That's the philosophy that I operate from. Thinking about it in those terms. Okay, so Michael goes on to say here's an example of a vector, and it's a set of words, the, quick, brown, fox, jumped over the lazy dog. And there's not much a machine learning system can do with that, but it's a vector. Being a vector, the sentence can be transformed into something else. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the same vector in a different format. The words have been converted into numbers in the sequence in which they could occur, and he could do this for a lot of words. Then you could compare many sentences and phrases and look for patterns. Maybe certain phrases occur over and over and over again, right? Something to think about. But that's not very useful. To approximate something like understanding, which algorithms cannot achieve yet, we need to find relationships between words and phrases. Now, these relationships might mean something in a linguistic sense. Prairie dogs can talk about relationships to another, but computers have short-term memories. Now, BERT, bidirectional encoder representations from transformers. We did a video on that too when Google made that announcement. A lot of people talked about that. And, okay. How Michael sees that is BERT is the cooking oil that you use to grease a saucepan before you start preparing a meal. That's BERT's place in the world of computerized semantic analysis. BERT studies groups of text and looks for patterns in them. And he wrote an article, I guess, for his newsletter. And what he says, there's 12 points to BERT. It saves other machine learning tools by pre-labeling words in a corpus, meaning a large body of text. It only works with phrases or sentences. It uses special stacks of special chips called TPU pods, using TPU version 3 chips, this is really fast processing. Its accuracy and reliability increases as it processes more text, so kind of self-learning. It randomly blanks out or masks about 15% of the words fed to it. Again, why would it do this? To try and do predictive patterns. It compares the phrases or sentences to each other to find patterns that predict which words will best fit into the blanks. This is another reason why you're seeing predictive text in your Gmail. Yes, that's part of it too. This training method was first developed for teaching school children in the 1950s. It uses about 20 to 30 more processing power than other machine learning systems like Elmo. BERT enables Google's machine learning experiments to complete in minutes rather than months. And other people using BERT will need to lease Google's cloud TPU technology or invent their own equivalent technology. And TPU chips have more onboard RAM than the most powerful gaming PCs, and they can only process certain types of matrix operations. Okay, the bottom line here. They're trying to figure out meaning predictions of language by predicting word patterns. So they're analyzing patterns. They're at that stage of machine learning. Okay? Not understanding necessarily. It's not like a brain, but they're looking for patterns by looking at large amounts of text and predicting what words are going to fit. Okay, but BERT is not really processing the text backwards and forwards. Okay, so this is from an article from Toward Data Science. Describes it. BERT is considered bidirectional, though it would be more accurate to say that it's non-directional. This characteristic allows the model to learn about the context of a word based on all of its surroundings, left and right of the word. So reducing the discussion of BERT to the simplest terms possible, web marketers got it wrong. It doesn't produce any scores for documents. Its results are not used to select and rank search results. It teaches other algorithms, including presumably the selection and ranking algorithms, to better understand the language of the documents they're processing. He goes back to his analogy of the quick brown fox jumped over the lazy dog as a vector, where each word can be a number in sequence. You can't do much with that, but you can annotate each element in the vector with data that can be used by procedures and functions within the algorithm. So each number has data. And what goes out in it, is attached to each one of those things, whatever the computer scientist wants to attach to it. So they might be writing instructions in some kind of metacode. They could be doing whatever to it. Again, you're trying to teach the algorithm to pick things that a human being would pick. And this is, and right about this part of the article, what I started to think about was EAT. EAT, expertise, authority, trustworthiness. And this is a thing that a lot of people talked about. Everybody said, hey, expertise, authority, trustworthiness, put those author bio boxes on there, get experts to write on your thing, on your blog or your site, and you should rank higher. If you've been in your business for like decades, then you should be trustworthy. Human beings would trust you, right? But Google doesn't. And I answered several videos on this too, where people were writing in forums and they were saying that they did exactly this. They hired experts to write for their blog, for their site. And their material was original. It had expertise. But something was missing because Google did not rank their sites any higher. That's what I thought of when it came to this part of this blog post here. That's exactly what I started to think. Because in a human mind, you would think that, oh, I recognize that article is being having a high level of expertise. Now, why would you think that? Not just because somebody, Dr. So-and-so with a PhD wrote it, but because of the way that it comes across. It's written in a way, when you read it, it seems to sound like the person knows what they're talking about. Now, even if you come across a subject where you personally don't have any expertise and you don't know anything about it, you've read articles before. I've read many, many articles over the last couple of years about subjects that I did not know a lot about, didn't know anything about. But you can kind of tell by the way that somebody writes whether they have expertise or not. So that's something that I thought about right here when we're talking about words in a sentence and trying to analyze the context and the meaning of each word in a sentence, in a page, by looking at the words that are to the left and the right and above and below and in the rest of the page, getting context for each word. That's what I thought about. Okay. So simple pattern analysis will not get you there, he goes on to say. When you're talking about the difference between a quick fox, a quick runner, a quick man, and a quick lime, okay? Pattern analysis won't get you there. Machine learning experiments still rely on human classification because algorithms cannot understand language. And one of the many goals of modern machine learning is to develop self-classifying systems where the algorithms can pluck out accurate relationships from a huge blob of texts that use words in many different ways. But in computer science, neural matching, this is a big deal. About being able to identify the capitals of countries and subregions just by analyzing texts. Because it's a far cry from figuring out whether Paris, the word Paris by itself, refers to a city, a person, the French government, or a political agreement. This is something that we talk about too when, why short tail, like one word or two word phrases, oftentimes you'll see mixed results in the top 10. And that first page of results, you'll see mixed results. But usually what's up in the top, like top 4, top 5 results, will be what Google has the most confidence or believes that the majority of people are actually searching for with those short phrases. But you'll see mixes of different things. So over time, it probably does see if their assumptions are correct. Okay, so algorithms don't know what cities are, don't know what people are, don't know what governments are, don't know what political agreements are. But the more data a machine learning system can associate with any word or phrase, the better that system becomes at matching patterns. That's the point that Michael's trying to make. Okay, the entity graph is a thing. People talk about that, the knowledge graph, the entity graph. But again, when you use, here's a great example. When somebody types in John Locke into a search engine, do they mean the philosopher? Do they mean the character from the TV show Lost? Do they mean me? Do they mean somebody else? There's another web developer out there in Seattle. Maybe they mean him. There's an artist in New York named John Locke. So it could mean many different things. But what Google is going to say most of the time, if you just type in John Locke without any other modifier, it's going to think that you mean the philosopher. Because that is what the majority of people mean. But maybe not you. So again, Google's not omnipotent. It doesn't, know for certain. It just makes predictions. Okay, so Michael goes on to say here, matching 2 or 3 vectors to each other doesn't really accomplish much. The objective with pattern analysis is to identify one or more rules by which you can make pretty good predictions. Oh, I totally forgot about reading this part, but yeah, it's something like what I just said. Okay, I wouldn't even say reliable predictions. The goal is to make predictions you can work with, but which don't have to meet a standard of perfection. Given a phrase like the quick brown fox, a machine learning system should be able to predict that jumped over the lazy dog is likely to come next or may be used within close proximity. These predictions will not always be right, but the more text that an algorithm can process and annotate, the better its predictions become. And these systems process hundreds or thousands or millions of vectors of digitized text. They cannot process everything, and it wouldn't make sense for them to do that. But much like language, machine learning must also digress into dialectical translations. To make better predictions for jargonistic language, the algorithms must learn from and identify the relationships between words and phrases in jargonistic sources. So he goes on to say that every time that he reads Google trains an algorithm on Wikipedia articles, he wants a gag. And he understands why they do this, just to develop the algorithms, hopefully, but the data must be cleaned up later. A lot of people do believe that is what they use as like an initial seed source for subjects, though what I've seen too, it's definitely not the final thing, but it's a way to start the process of learning about a given subject. And Michael says, Wikipedia is convenient because it publishes millions of articles that anyone can download, but Wikipedia speaks language even Wikipedia doesn't understand. It's not relevant to real-world human speech and writing. And he says, only one person has written this blog post that you're reading right now, but any Wikipedia article that's been around for years has been edited by many different people. So he goes on to talk about BERT, and he's saying, these systems are computing a lot of weighted averages that help Google normalize data and look for patterns. Again, vectors, you're looking for patterns. Why is this important in SEO? You're looking for patterns anytime you're looking at not only things that appear in the page, you're thinking about things that are mentioned in the page, questions that are answered in a page. When you look at things that tend to rank well, you want to be looking for commonalities because those are probably vectors within the algorithm where they've detected things that say these elements or these questions that are being answered or these phrases tend to make our users happy. Remember, how do we measure user signals? Real world user signals, not gaming the system. We're using real user signals to determine happiness, whether people are satisfied with the page. So gaming the system is definitely not a thing that can be done anymore. Which is why writing and design and the presentation is very important. Keep that in mind. But it's looking for these patterns because in the past it's made people happy when they've done this particular query. So that's what struck me about this is it's putting a lot of the things that I feel, or at least certain parts of this article. It doesn't have to be the entire article, but there are definitely things in this article where I felt like, yeah, these are things that I believe, but they're being expressed in a different way. They're being said, it's being said with different words, but these are concepts that I've been talking about because I've noticed it as well. Anyway, wrapping up. Michael says, when you type a query into Google's search box, it will be vectorized later for analysis. And when Google suggests ways to complete the query, they're showing you predictions that their algorithms made. They're using vector analysis in a lot of interesting ways. More than one person can comprehend or explain, but they're a stepping stone on the way to something else, which is true like neural matching, true neural net. And you don't need to influence vector analysis to improve your rankings because you really can't. The data set is too big. The user signals, they're too varied. You're not going to be able to game the system for long. That's what I'm saying to you. You know, a lot of people have a very archaic way of looking at SEO. And like I said before, the conversations that I had this week, the client that wanted to, or the prospect that wanted to hire people based on price alone because they figure like everybody thinks the same way and everybody delivers the same work. Anybody that works in SEO can tell you that that's totally not the case. That's way not the case. The other thing, I had a conversation with a person. They were asking about a certain type of website, and I was saying that what I noticed was there is a pattern in any city that you would be in the world. If you were trying to rank for this certain type of site, there would be a set of websites that seem to correlate with higher rankings. If they had a link from these certain sites, there is a correlation. And this person said, I feel that this website should be in the list. Well, that website was not in the list. And I'll have to follow up and ask this person. But I showed them a list of sites that seem to correlate with higher rankings for this particular thing in cities all over the world. And I just want to see if that was very surprising or not. I just thought it was insightful to me, I think, as someone who studied that type of site for the first time like last year. I just thought it was very interesting to see what types of sites Google correlated with quality when people got a link from that particular site. Very interesting. So these are vectors. When we talk about the link graph, that's also a vector of things that might correspond with a site that deserves to rank higher. So just things to keep in mind. Vectors are not math, Michael concludes. They're just things. Math represents what we do with the things, and they point at what we hope to get. The SEO, and he says the SEO discussion should have never been weighted down in vectors. I don't know where he saw this. I'm not sure. But you can't just download Word to Vec and become an expert in vectors, machine learning, or semantic analysis. This guy has interesting things to say a lot of the time. So just another voice out there that you probably should, be open to hearing from. Like I said, a lot of stuff that I get ideas from, it's not necessarily the things that people say directly to me, but the things that people say, it reminds me of something else, which gives me an idea. So just something very interesting. I would love to hear what you guys have to say, what you all have to say. Anyway, my name's John Locke. My business is Lockdown Design and SEO, and I'm here every single day making videos on SEO. And God, how many videos do I have now? Like 550 or something. Almost 100,000 views. Getting closer. Probably hit that by March. Sometime in March. We got 500 subscribers. We're trying to get to 1,000. So if you want to subscribe, hey, daily content. Would love to hear from you. Leave a comment on this video. Tell me what you want to see. If you have a question, leave it in the comments below. I respond to all my comments. So, don't be shy. I'll be here tomorrow with a brand new video, and until next time, peace.